Okay, in this section, we're going to talk about intervals and inequalities. This is section A9. This is at the end of the book. And so let's get right to it. And the first thing that we'll look at is interval notation. As an example, suppose that we have something written in set builder notation, set of all x such that x is less than 3. As an interval, I'd write negative infinity to 3. Because I'm not including 3, I'd want a parentheses there at 3. Anything not including 3, but less than that means that I'd be shading towards the left and not including 3 there. Set of all x such that x is greater than or equal to negative 7 means that as an interval, I'd write negative 7 to infinity. And I'm including negative 7, so I'd want to include negative 7 in my my answer if I were to graph on the number line. By the way, there is an order to how we should be writing things in interval notation. You always want the smaller number first, bigger number second. So I wouldn't write infinity comma negative 7. That makes no sense. Here's another way on the number line. Instead of using parentheses or open and closed circle, I can use parentheses and brackets. Use a bracket if you're including the number, parentheses if you're not including the number. Okay. Suppose that I had the set of all x such that x is greater than negative 1 and less than or equal to 3. As an interval, negative 1 to 3, I'm including 3, so I've got a bracket there at 3, and here's what that looks like on the number line. Here's another one. I got the set of all x such that x is less than negative 5, or x is greater than 3/4. So, as an interval, I'd write negative infinity to negative 5, or 3/4 to infinity. Some books use the union sign. I believe this one does. Instead of writing the word or, I like the word or. Or is only 2 letters. And so I use the word or instead of the union sign. It means the union sign. So there's no problem there. I'd want a parentheses by negative 5 and 3/4 since I'm not including those numbers. And since I'm not including those numbers, I'd want a open circle at negative 5 and at 3/4. Okay, so let's let A, B, and C be real numbers. If A is less than B, then A plus C is less than B plus C, and AC is less than BC if C is positive. If C is negative, then AC is greater than BC. Similar statements apply for if you have a greater than, a less than or equal to, or greater than or equal to. As an example, suppose that 1 is less than 2. Okay, if we multiply that by negative 1, negative 1 is greater than negative 2. Okay, same thing over here. If we have the statement 1 is less than 2, and we divide by negative 2 on both sides, negative 1/2 is greater than negative 1. So whenever you multiply or divide both sides by a negative, you got to flip the sign. As an example, suppose that 1 minus 2x is greater than 2 minus 3x over negative 4. If we multiply both sides by negative 4, negative 4 plus 8x is less than 2 minus 3x. Okay? Since I multiplied both sides by a negative, I got to flip the sign. If we add 3x and add 4, 11x is less than 6, and divide by 11. 11 is a positive, so I don't flip the sign again. X is less than 6/11. Okay, anything less than 6/11 means I'm getting towards negative infinity. And here's 6/11 on the number line. I want the open circle there, so I'm not including that start point. Okay. And here's another one. -2 times 5 plus 3x less than or equal to 6 minus 2 times the quantity x minus 2. Okay, if we distribute -2 into the two terms, -10 minus 6x less than or equal to 6 minus 2x plus 4. 6 plus 4 is 10. And if I add 10 and add 2x to both sides, -4x less than or equal to 20. If I divide by -4 on both sides, I'm dividing by a negative, so I got to flip the sign. And x is greater than or equal to -5. Okay, so as an interval, I'd say the interval -5 to infinity. And make sure there's a bracket by -5. And I'm including the start point there. Anything bigger than that. Okay, the expression a less than x is called a compound inequality, and it means a less than x and x is less than b. So for example, suppose that -4 is less than or equal to 9x plus 14, which is less than 21. If I split the compound inequality, -4 is less than or equal to 9x plus 14, and 9x plus 14 is less than 21. Subtract 14 from both sides, so -18 less than or equal to 9x, and 9x less than 7. So if I divide by 9 on both sides, x is greater than or equal to -2, and x is less than 7/9. Okay, and I'm going to put this back together as a compound form. X is greater than or equal to -2 and less than 7/9. So since x is greater than or equal to -2, I'm including -2. I'm not including 7/9, so I'd want to make sure I've got a closed circle there at -2 and an open at 7/9. Okay, and suppose that 1 is less than or equal to 4x minus 5 divided by -2 less than 9. Less than 9. If I multiply both sides by -2, the fact that I'm multiplying throughout by a negative means I got to flip both of the signs. So -2 is greater than or equal to 4x minus 5 greater than -18. If I add 5 throughout the three parts, -2 plus 5 is 3. I got 4x in the middle. -18 plus 5 is -13. Divide by 4, and so 3/4 is greater than or equal to x, which is greater than -13/4. Okay, and I've written that as a compound form. Like any other compound inequality, we usually write the smaller number first, bigger number second. And so here's my answer. The set of all x such that x is greater than -13/4 and less than or equal to 3/4. Since I'm including 3/4, and I want a bracket there at 3/4. Again, a closed circle there at 3/4, and shading between the two circles. Okay. And definition, let's let a be greater than 0 and u be an expression involving x. Then x greater than, or x less than a, the, the absolute value of u less than a means the absolute value of u is greater than or greater than negative a and less than a. And the absolute value of u greater than a means that u is greater than a, or u is less than negative a. Okay, one of the things that I'd like us to do when we read the definition is to notice which way the sign is facing, because that plays a huge role in which inequality we're going to write, resulting with no absolute value bars. In fact, here's one way to remember this and versus or business. Step one is you want to get the absolute value of u alone and on the left. Okay? So if you're adding anything, or if you're multiplying by anything, go ahead and clear that out. And so step two, if the sign is greater, like it is here, you're going to write or, and I've misspelled the word greater. You're going to write the word or. One of the inequalities is going to be like the absolute value bars aren't even there. The other one, you're going to flip the sign and then throw a negative on the right. If the sign is less than, and I've got that misspelled, you're going to write and. Maybe you got a less than sign. And of course, if I split a compound inequality, I write the word and. Negative u is less than, negative a is less than u, and u is less than a. Okay? So, as in inequality, suppose that we have the absolute value of 3x plus 2 minus 6 less than or equal to 4. Okay, add 6 to both sides. And the fact that that's a less than or equal to sign means that, like the definition says, I'm going to write a compound form and lose the absolute value notation. So negative 10 is less than 3x, less than or equal to 3x plus 2, less than or equal to 10. And I've split this, I didn't need to, but negative 10 is less than or equal to 3x plus 2, and 3x plus 2 is less than or equal to 10. If you subtract 2 from both sides, then negative 12 less than or equal to 3x means that negative 4 is less than or equal to x, and 3x less than or equal to 8 means that x is less than or equal to 8/3. Okay, so as a compound form, we got the set of all x such that x is greater than or equal to negative 4, or less than or equal to 8/3. If we use an interval, negative 4 to 8/3 would be the answer. I'm including both the numbers there at the end. So negative 4 to 8/3 is included. Okay, so another one, the absolute value of 7x minus 1 is less than, or is greater than, or equal to, or greater than 6. So 7x minus 1 is greater than 6, or 7x minus 1 is less than negative 6. Okay, if I add 1, 7x is greater than 7, means that x is greater than 1, or 7x is less, 7x is less than or equal to, or less than negative 5. And so divide by 7, x is less than negative 5/7, which is right there. Okay? So in all, and I've got this written in such a way so that the way that you read it, you know, is set of all x such that x is less than negative 5/7 or x is greater than 1. Now, what's wrong with you know, thinking about this as a compound inequality and writing as a three-part inequality? Well, as a three-part, you'd be saying that 7x minus 1 is less than 6 and greater than negative 6. But then when you apply the definition for absolute value, you'd be saying that 1 is less than x, which is less than 5/7, which makes no sense. So or is the key word that needs to be written here. Okay, or the union sign is the same thing. So negative infinity to negative 5/7 or 1 to infinity. And since I'm not including either one of those, I have open circles there on both ends. And one thing that I want you to notice too is that right off the bat, I can know how this is going to look on the number line. A greater than sign means that you've got the two numbers there, and you'll be shooting off in different directions. A less than sign, or less than or equal to, means that you got the two numbers and you'll be shading in the middle. Okay. The absolute value of 2x plus 1 less than negative 1. Okay, no solutions would be the answer to that one. If I let x be anything, x could be, 1 or negative 3 or anything. The absolute value bars means that I've got an overall non-negative number less than negative 1. There's no non-negative numbers less than negative 1. Okay, so that's why the answer is no solutions. The absolute value of x of 2x plus 1 greater than negative 1. Well, if x is anything, is negative 1 or 3 or whatever, the resulting number on the left is always going to be a positive. Okay, all positive numbers are bigger than negative 1, so all real numbers are going to be the answer to that one. Okay, and that's really kind of just a think about it and go right to the answer type thing. The homework is on page A83. I've got problems listed there that I'd like you to look over. So be sure that you look at those.